For those of you who cannot see the whiteboard, study for exams, right? Okay. That's not the way to spend a holiday, but I think you all have no choice because exams are coming up. But good job. Went to temple. Okay, yesterday is a poor day. So some of the Buddhists must have gone to temple. Tomorrow you have maths. Right. Okay. Then I think today discussing this exercise will be a good revision, no? All right. So we are starting with congruency, miscellaneous 8th question. Your exams are over. All right. So then for some the exam is over, for others the exam is still ongoing. This is something from lesson 5. This is lesson 5 miscellaneous. Once we are done with lesson 5 miscellaneous, let's go to lesson 6. That's 6.1 and all the home. Okay. All right. All right. The point X lies. Did we not discuss this last week? We discussed this last week, no? I have a memory of discussing this. Can you all check quickly? Yeah, we were doing binomial
expression. It's not question number 8, it was question number 9.
Question number 9. Right. Okay. I'm sorry, my bad. We were doing the factors of quadratic expressions, but we have homework from the previous lessons. So that is what we are discussing now, simply. All right. The equilateral triangles BCF and DCE are drawn on the sides of BC and DC of the square ABCD. Okay, so we clearly have a square ABCD, right? So we have a square A, B, C, D. So the equilateral triangles BCF and DCE. BCF. BCF goes like this, no? BCF. And DCE. So DCE should come from here. DCE, like this. So this is a square and these are equilateral triangles, right? So I will mark that this is a square and wait. It's the 8th question in the whiteboard. Lama, others also, can you all let me know? Did I give because 8th question, I remember we discussed it during the class. Did I give the 9th question as homework or not?
Yes, miss. You gave the 9th question.
Okay, others?
Gave the 9th question.
Right. Okay, then Alia, I think there must have been a mistake. Did I send last week's whiteboard note? No, 1 second. I will quickly check. Did I send last week's whiteboard? I have not sent last week's whiteboard note, no? So I suppose then there must have been a mistake. Okay. So this is the equilateral, this is the square and square, maybe the path is equilateral triangles. So then if this is an equilateral triangle, this side is equal to this side is equal to this side. And this side is equal to this side is equal to this side. Okay. So it says my connection is unstable, so I will keep my camera off for a bit. Okay, then draw a rough sketch illustrating the above information. Show that EDA is congruent to ABF. Okay, let's see. Where is EDA? EDA kila already draw karapu triangle ekak na. We will have to draw it separately. So E here, D here, A here. So I will connect this. Sorry. I will connect this. So I have a triangle EDA. Right. This is one of the triangles. Like this. Then switched on my camera. I hope you know. ABF is this
Miss, it's getting stuck.
Is it? Okay, I'll keep my camera off then for some time. So EDA and ABF is there. So these are the two triangles that we have to consider, right? That means triangles they congruent karanna yone. What case should we use to make these two triangles?
Miss, you're breaking.
What is the case you use? Can I know?
Miss, can't hear you clearly.
Second. Tame, how about now? Can you hear me now? All right. So if you made these two triangles congruent, can I know what is the method you used? What is the congruency case you used?
SAS.
Ismail says SAS. Others, what do you think? Okay, so I got two more answers saying SAS. All right, let's see.
Say
Okay. This side and this side are equal. So we have one pair of sides. This side and this side are equal. So we have another pair of sides. It says nang equal sides the katare angle also should be equal. This is a square. So we know this is 90 degrees. This is also 90 degrees. This is equilateral triangle. Then this should be 60 degrees. This also should be 60 degrees. Ena dennage me ekat equal, right? So ekene ba mulim angles story ka liyala inna. Okay, so I write this angle is ADC, right? ADC is equal to this angle is ABC. ABC. Why are they equal? Sides of a square. Sides of a square, because we know sides of a square are equal. Then on the other hand, we know that this angle and this angle are equal because they're both equilateral triangles and we know the angle is equal. මෙතන ළමයි sides of a square නෙවෙයි. Interior angles of a square. Sorry. Interior angles of a square. ඔයාට ඕන 90 degrees කියලා දාන්නත් පුළුවන්. Then what is my other angle? CDE. CDE equals මේ පැත්තේ CBF. For that, the reason I write interior angles of an equilateral triangle. Now, according to an axiom, we add ADC, CDE when I'm add karno, ABC, CBF when I'm add karno. So, ADC plus CDE equals ABC plus CBF. Okay. Then ADC plus CDE. So ADC is here, CDE is here. Add karam apita na mein ADE කියන ලොකු triangle එක. So when you add these two, you get ADE. Then ABC and CBF are these two angles. When you add, you get the big angle ABF. So these two are therefore equal. Now I write my congruency case. Now congruent කරන්න ඕනේ අපේ EDA triangle and ABF triangle, right? I'll put the topic EDA and ABF. So our sides AD is equal to AB. Then ED is equal to BF. May දෙකටම reason එක given, no? Here both instances they have given. නැත්නම් ඔයාලට කියන්න පුළුවන් sides of a square, sides of equilateral triangle කියලා. එහෙම කියන්නත් පුළුවන්. Sides of square sides of equilateral triangle. Did you get the recording? You must not have gotten the recording yet, no?
Yeah, teacher.
Did you get it?
No, teacher.
Okay, so when you get absent, make sure that you request the recording.
I requested the recording, but I didn't get.
Really?
Yeah.
Okay, I will check with Miss Divya regarding that. Okay, so were you only absent last week? I suppose is 25th, right?
Yes, teacher.
So were you only absent on 25th?
Yes, teacher.
Okay, 25th recording was there, I think. I'll check with her nevertheless, and I'll ask her to get back to you. Okay?
Okay.
Okay. So here, make Rapalina proven above. Therefore, triangle EDA is congruent to triangle ABF under the SAS case. So you guys are right. It is the SAS case. Good. Then what is our second one? EAF is an equilateral triangle. So before that, can you all, I'll give you 2 minutes for recorrections. Make it fast. I'll give you 2 minutes for recorrections. Yes, it's mine. Yes.
For AD equals AD and ED equals BF, can we write for those given?
Which one? Can you go again?
For the AD equals AB and the ED equals BF.
Yeah, I could have given them at Aulak now because it was anyways given in the question, so it's all right. Okay? All right. Okay, your 2 minutes start now. Quickly do the recorrections. All right. Let's move on to the next one. EAF is an equilateral triangle. First of all, EAF ke triangle ekak metan naha, right? We have E, we have A, we have F, but we don't have a triangle putting them together. So because of that, what I'm going to do is I'm going to draw a line here. E nang A venakang there's a line. A to F there's a line, but E and F connect in a line ekak naha. Hence, I will draw a line as such. Now, what is the triangle that we are considering? The triangle we are considering, oh no. Let me redraw this again. I drew a line connecting E and F. So now we are considering this particular triangle, which is quite a big triangle, no? Apit pennanda one me denna make a equilateral triangle ekak kiyala. Here, if you see, EA and AF are anyways equal. Why do I say that they are equal? EA and AF, they are equal. Why? And how?
Because triangle EDA and triangle ABF are congruent,
Yeah, so
and there are
corresponding sides, no?
corresponding sides of congruent triangles.
Good. Very good. That's why. Because we already proved that the two lean triangles here, this is EDA and there it's ABF, they are congruent. So we can say that corresponding sides of congruent triangles are equal. Therefore, AE and AF are equal. Now our problem is this side, which is EF. What do I do for this? How did you all do? Can you all suggest different methods that you may have used for your answer? What can you like? You can even give an idea. You don't have to give the entire answer, but just an idea. Hmm? Did you do this homework? I'm not very happy with your answers or your responses. No?
EA equals F corresponding angles of congruent triangles.
EA. Okay. And then what?
AF corresponding angles of congruent triangles.
Corresponding sides of congruent triangles is okay, but corresponding angles of congruent triangles. Do we really need that here? No. Anything else? Let's have a discussion. We're discussing the homework. What about others? Senudi, Sandaru, Joshua, Shweta, Venuja, Shanaz, Savindu, Smail, Alia, Basma, Kushit. Kushit just said an answer. Some of you are actually speaking. That's good. I need others' answers as well. One of the ways would be, if we have a way to like, let's say, make this triangle and this little triangle congruent, we can say this and this sides are equal, corresponding sides of congruent triangles again. That is one method. Do you all have any other methods that you used? All right. If you have other methods, please let me know. But I will use the method that I said, right? Mama consider karanawa menna may chuti this little triangle which is ABF and this triangle which is ECE, right? If you take this to, I'll color this triangle so that it's easier for you to see. මෙන්න මෙයාවයි මෙන්න මෙයාවයි. Here we can see that this side is equal to this side. Single line. Then this side is equal to this side. So that is also okay. What else is equal here? Can you see now here, this particular angle, here 90 degrees, here this is 60 degrees. So 90 plus 60 is 150. What about the angle here? Do you think it's 150? Yes or no? Okay, api ek balon. Let's see. Yes, Basma, what do you think?
It's not 100. It's not 90 plus 60.
It's so here this is 90 plus 60, that is 150, right? Is this 150?
No, it's way more than 150.
It's not 150. All right, let's see.
No, this is not 150.
It's not 150.
No.
It's not. Okay. So Basma says it's not. Samidu says it's not. Okay. Hari, api balamu. Let's first start with this angle ABF. Right. So where do I have space? Shall we do it here? May patte. So gala answer copy karagadi, don't get it confused. I just need to have the diagram close by. Ekinda ma may patte karanawa. So we're discussing Roman number 3. So we are talking about angle ABF. Angle ABF is made of, ABF is equal, this little triangle angle which is 90 degrees ABC, and this angle which is CBF, ABC plus CBF. ABC plus, one second, let me make the board a little bigger, CBF. And we know ABC, as we can see, is 90 degrees. CBF is 60 degrees. So 90 plus 60 is 150. All right, that angle is 150, no problem. Let's check this one, ECF. Now, how do we exactly check this? Do you know that angles around a point is 360 degrees? Angles around a point is 360 degrees. Do you know that?
Yes.
Yes. Yes. So if you take this point C, the angles around it should add up to 360, right? So what are the angles around it? We have this one. Sorry. We have this one, which is 60 degrees. We have this one, which is 90 degrees. And we have this again, 60 degrees, right? And we have this, that is what I want to find. Okay?
What does that angle thing mean?
Sashil, are you asking something? I can't hear you.
What does that the angle thing you meant to say?
What I said was that if you take a point, around a point, all the angles, like the angle around a point is 360, right? Do you remember that?
Yes, teacher. I didn't heard you the first time. Thank you.
All right. Now it's clear, no? Okay. So let's see ECF. So I'm going to add all the angles around the C point. One is ECF. Then we have ECD. Plus we have BCD. Plus BCF. So these are all the angles around the point C, and that is equal to 360. So you can write angles around a point. Now ECF, I don't know the value. ECF can mama danne naha. So I just leave it as it is. ECD here is 60 degrees because it's an interior angle of an equilateral triangle. So it's 60 degrees. BCD is 90 degrees Then BCF is also 60 degrees. 90 degrees plus 60 degrees equals 360. So we get ECF plus 60 plus 60, 120, 120 plus 90 is 210. Equals 360. Then ECF is 360 minus 210, which in fact is 150. Okay, so that actually is 150. So you will have to do the calculation to see if it's actually equal. So ABF is 150, ECF is 150, therefore ECF. Up to that point, is it clear to all of you, Lamai? Please give me a thumbs up. All right. Now let's do the congruency part. I'm going to consider triangle ABF and ECF. So ABF and ACF. Not ACF, it's ECF. No, I'm sorry, it's ECF. ECF. The sides are equal. AB equals EC. AB equals EC. Then BF equals CF. Also equal to, we can prove that these two triangles are congruent under the SAS case. We'll write the reasons, but then you can just write given. Here also you can write given. Here you can write proven above. Therefore, triangle A, I'm sorry, my handwriting is not that good. Okay. Therefore, triangle ABF is congruent to triangle ECF under SAS case. Now, if these two triangles are congruent, we know AF කියන side එකයි EF කියන side එකයි equal, right? Therefore, the side AF and side EF will be equal because they're corresponding sides of congruent triangle. So, AF equals EF. Reason: corresponding sides of congruent triangles. At the same time, අපි කලින් කිව්වා AE equals AF2. AE equals AF. අපි කලින් question. In the previous question also, we proved that those two triangles are congruent. So under that, these are corresponding sides. Therefore, all three sides are equal. No? Therefore, AE equals AF equals EF. Therefore, triangle EAF is an equilateral triangle. Is this clear to all of you? It is quite long. You can make a ninth question, and then the question becomes a little like, little by little, it gets more complicated. That's why this is the ninth question. So then we have 10th questions and 10th and 11th questions also, which we will slowly but surely discuss. I told you, like, we are spacing out homework. දවසට එක ගාන හරි කරොත් අපිට ගොඩක් කල් අර එක refresh කරගන්න පුළුවන්, right? So that you don't forget. Anyways, 2 minutes to copy this down. I'll give you 3 minutes for that because it's slightly longer. But quickly do. Make it fast. Quickly copy down. Quickly fix your mistakes, whatever. Okay, Lamai, done?
Please, can you give 1 minute?
Sorry, Ismail?
Can you give 1 minute?
Yeah, for sure. Quickly. All right, Lamai. Others? All good? Shall we move on? Excuse me. Can you all tell me what the next homework is? I believe it's exercise 6.1. Which question in exercise 6.1 exactly? 6.2. All right. 6.2. Wait.
6.2, question 5 and 6.
6.2, question 5 and 6, both, no? Let me get question 5 to the board. This is 6.1 exercise 6.1, question 5. Up with the topic as well. Pass it whiteboard එක බලන කෙනෙකුට හරි මේක නැත්තම් තේරෙනවනේ. Okay. The following is a figure consisting of two sectors of circles. Show that the ratio of the area of the smaller sector to the larger sector is 1:3. So that means we have to find the area of the smaller sector and the larger sector, right? So let's first find the area of the smaller sector. And now we know the formula for finding the area. Theta over 360. Maria, we are still discussing homework. We already discussed the congruency question. We are in exercise 6.2, fifth question. So our formula is theta over 360 multiplied by pi r squared. So smaller sector wala theta is 45 degrees, right? It's just 45 degrees. 45 degrees divided by 360 multiplied by pi. Pi is 22/7 multiplied by r, radius. What is the radius of the smaller sector? What is the radius of the smaller sector, Lamai?
14 centimeters.
Okay, others, do you all think 14 or any other answers?
14 centimeters.
14. Because the big sector has 21 centimeters, this little gap is 7, so 21 minus 7 is 14. 14 multiplied by 14. Let's cut and chop. Balu Mitana, 7 times 1 is 7, 7 times 2 is 14. 2 times 1 is 2, 2 times 180 is 360. Then 2 times 11 is 22, 2 times 90 is 180. Then 45 times 1 is 45, 45 times 2 is 90. Then, මෙතන තව 14 එකක් තියෙනවා 2 is 2, 2 times 7 is 14. So we have 11 multiplied by 7, which is 77 square centimeters. It's area, so we have to put square. Did you all get that, Lamai? Did everybody get that? Give me a thumbs up if you got that answer. All right. Then area of the largest sector, again the same formula. I will straight away do the substitution. What is the area of the largest sector? Sorry. What is the angle at the center of the larger sector? 45 plus 15, that is 60. Yes.
60.
Yes. 60 degrees divided by 360 multiplied by pi is 22/7. And what the radius here is 21. It's very strange. They have given it as 21. So 21 multiplied by 7 times 1 is 7. 7 times 3 is 21. 3 times 1 is 3. 3 times 1 is 3. 3 times 2 is 6. 0. Here 0, 0 cancel venava. 6 times 1 is 6. 6 times 2 is 12. 2 times 1 is 2. 2 times 11 is 22. So what do we have remaining? 11 multiplied by 21. So we will have to do the multiplication, of course. 21 multiplied by 11. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. 1 times 2 is 2. So 1. 2 plus 1 is 3. And 2. So this will be 231 square centimeters. What they're asking us to show in the question is ratio of the smaller area of the smaller sector to the larger sector is 1/3. Let's see. Area of smaller sector to area of larger sector. Now we know area of smaller sector is 77. Mama unit because we are talking about ratios, right? Larger sector 231. May then 7 gang divide karan pulan, so I will divide both sides by 7. So 7 times 11 is this. 7 times 3 is 21. 22, 23. 7 times 3 is 21. And then here have a 2 remaining. 7 times 3 is 21. Then both sides can be divided by 11. I will divide. We get 11 times 1 is 11. 11 times 3 is 33. So we do get the 1:3 ratio. Is this clear to you? Quickly give me a thumbs up, Lamai. Others, what about others? Smile, Basma, Shanaz, Savindu, Shweta, Sandaru, Maria said yes earlier. All right. Okay, 2 minutes to copy down. Make it fast. Copy down as in if you have done any mistakes, if there's any recorrections, quickly copy down. 2 minutes. Okay, Lamai. Done? Shall we move on? What is the next question that we have to discuss? Somebody quickly tell me what is the next question we have to discuss?
Question number 6 of
I
6.
say, right. Yes. Talked about this earlier. I forgot. Sixth question of the same exercise. I got the question to the whiteboard. Based on the measurements given in the figure, show that the area of the unshaded region of sector is 7 times the area of the shaded sector. So let's first find the area of the shaded sector. Our formula we know is theta over 360 multiplied by pi r squared. Shaded part gatham, it's a semicircle, so the angle at the center is 180. So I will write it 180 over 360. මෙතන 180 over 360 නැතුව කෙලිම 1 over 2 කියලා ලියන්නත් පුළුවන් since it's a semicircle. I think that question was asked from me a previous week. Semicircle එකක් නම් මුළු, I mean, you don't have to write all the angles and divide and all that. Instead of 180 over 360, you can just write 1 over 2. Now, what is the radius of this little shaded sector, Lamai, semicircle? What is the radius of the little sector?
It's 3.5 centimeters.
Yeah, because diameter is 7, so half of this diameter will be the radius. So you can either take it as 3.5 or you can take it as 7 divided by 2. It's the same thing. R squared hinda dekak liyanna ඕන. 90 over 360 you can't get for the shaded sector because shaded one is a semicircle. Then it's 1 over 2. That is 180 over 360. But if you take the unshaded one, මේ ලොකු සෙක්ට් එක ගත්තොත් එහෙම එයාගේ නම් it's 90 degrees. එයාට අපිට 90 over 360 ගන්න පුළුවන්. All right. So let's chop. It's okay. 7 times 1 is 7. 7 times 1 is 7. 2 times 1 is 2. 2 times 11 is 22. Seems like there's nothing else that we can cut and chop. So 11 times 7 is 77. 77 divided by 4. ඔහොමනේ තියෙන්නේ මම මේක මෙහෙමම දැන්ට තියන්නම්. තියලා අපි unshaded area එක බලමු. Unshaded region of the larger sector. Before I find the unshaded region of the larger sector, I have to find the area of the larger sector. I have to find the area of the larger sector, and from that I have to subtract this part. Then only I get the unshaded region. Okay. So I will say area of the larger sector. It is 90 over 360 multiplied by 22 over 7. And if you take the larger sector, radius is 7 plus 7, which is 14. So 14. Let's simplify. 1, 4. Then 7 times 1 is 7. 7 times 2 is 14. 2 times 1 is 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 7 is 14. So what do we have remaining? 22 times 7. 7 times 2 is 14. 1 remaining. Then 14 plus 1, 15. We get 152 square centimeters. That is the area of the larger sector. But we want the area of the unshaded part only. So for the area of the unshaded part, I have to subtract the area of the larger sector, which is 154 square centimeters. From that, I have to subtract the area of the small one. දැන් මෙතන අපි මේක simplify කරේ නැහැනේ. So ඔයගලන්ට ඔයාලට මෙහෙම දාන්නත් පුළුවන්. නැත්නම් simplify කරලා දාන්නත් පුළුවන්. I would say let's simplify and put. Yeah. Let's simplify. It's okay. කොහොම කරත් එකම answer කියන්නේ I was thinking what's easier. 4 times 1 is 4, 3 remaining, 37. 4 times 9 is 36. 1 remaining, 0 එකක් දාලා I put a decimal point. 4 times 2 is 8. 2 remaining, I put a 0, that is 4 times 5. So I get 19.25 square centimeters. This is the area of the smaller, the shaded part. So for area of the unshaded part, I take the area of the larger sector, which is 154 square centimeters. From that, I subtract 19.25. So let's do the subtraction here. 0 වලින් 5 subtract කරන්න බෑ. 10 වලින් 5 කියන්නේ 5. 9 වලින් 2 කියන්නේ 7. 4 නෙවෙයි 3. 3 වලින් 9 subtract කරන්න බෑ. 13 වලින් 9 කියන්නේ 4. And 14 වලින් 1 subtract කරාම that is 13. We have 134.75 square centimeters. Do we stop here?
No,
Do we
now
stop?
we show that the unshaded one is 7 times larger than the shaded one.
Yes. So we are going to check that, right? So, Manikandana, multiple of area of unshaded part of shaded part. Balum 7 times the Nikela. So for that, I take the unshaded part, which is, sorry, I take the shaded part, which is 19.25. And I multiply it by 7 to see if I would get this, right? Balamu. 7 times simplification ගොඩාක් හැමලේම ලොකුවට කරන්නේ නැහැ, but certain simplifications sometimes you get it confused. That's why I do it on the board. 7 times 5 is 35, 3 remaining. 7 times 2 is 14, 15, 16, 17. 1 remaining. 7 times 9 is 63. 63 plus 1 is 64. For them, how much 6 remaining? 7 times 1 is 7, 8, 9, 10, 11, 12, 13. Yes, in fact, we are getting that. So we can put a sentence at the end and write, therefore, the area of the unshaded part is 7 times the area of the shaded part. Is this clear, Amai? Is this clear to all of you? All right. 2 minutes for recorrections. Please make it fast. Lamai, while you write this, please give me a 1 second. What is this? 1.7 decimal is, what is 1.7? What do you mean 1.7? For which one, Saminu? For any day, if for any answer, if you're getting something that is not on the whiteboard, it's probably wrong. Check if there is any simplification mistake. No. Shaded part එක 1.7 වෙන්න බෑ. 1 second. So it has to be something that's here. Okay, Lamai. Quickly write this down. While you write this, please give me like 2-3 minutes. I will be back. Meanwhile, copy down. Okay, Lama. So, shall we move on to the next one? What is the next exercise that I gave? What's the next?
Exercise 7.1, second question, QRS and T.
QRS and P. Okay. Let's first discuss Q and R, exercise 7.1. Wait, QRS and QRS TR, right? Okay. Okay. So, A. Second ke A kalama, yeah? Second question A. Q. We have m squared minus 40 plus 6m. M squared minus 40 plus 6m. So, may format again that come, it's a bit confusing because that's not what we have learned. So, I'm going to just rearrange these a bit. M squared. This 6m I'm going to bring to the front. Plus 6m. And minus 40, I'm going to put it at the back. Minus 40. Like this. Now, this is something that we're familiar with. Okay. Okay, now let's see how to do this. We already talked about the steps. We take the first term and the last term and we multiply. First term is m squared. Last term is minus 40. So, may dena multiply karna. Multiply karahama, we get minus 40 m squared. Now, we have to find a way to get minus 40 m squared. And there are so many different ways, right? Up to pull on 1 times 40. 2 times 20, 4 times 10, 5 times 8, right? So, A options okkuma tiyena. So, for an example, if you take 2 times 2m multiplied by 20m, we know 2 times 20 is 40, m times m is m squared. But here there is a minus. Answer kata minus n when different signs are multiplied. So, either plus 2m multiplied by minus 20m or minus 2m multiplied by, plus 20m. So, our anithama option hai kada water me wage dekak liyan pola, right? 1 times 40, 2 times 20 is what we wrote here, then 4 times 10, 5 times 8. Or you can write 2 options with different signs, plus and minus. So, another one, as we said, 4 times 10. So, plus 4m multiplied by minus 10m or minus 4m multiplied by plus 10m. For others also, you can write all of this, but I'm just going to write a few because I know what the answer is. Okay. So, I think with practice, the more you do questions like this, the more you will find the answer quickly. Okay. Then what we are going to do is we are going to add and see. So, here plus 2m minus 20m. We get minus 18m. Is that what we have here? No, we have plus 6m. Minus 2m plus 20m. There we get plus 18m. Still not plus 6m, so let's keep it. Plus 4m minus 10m. Let's see, plus 4m minus 10m, which would be minus 6m. Close, but what we want is plus 6m. Minus minus 4m plus 10m. We get plus 6m. This is absolutely the one. Plus 4m plus 10m tamai endone. Because, sorry, minus 4m plus 10m. Because that gives plus 6m. And that is exactly what we want here. So we will rewrite this m squared plus 6m mama minus 4m plus 10m. Here we have minus 4m plus 10m. And at the end, we have minus 40. Now, if you take the first two terms, we have m common, I take m out, then we have m minus 4. Then we take the last two terms, we have 10 common, I take 10 out, then we have m minus 4. Then m minus 4 in one bracket. Outside, we have m plus 10. M plus 10 goes to the other bracket. Is this clear, Lamai? All right, 1 minute for mistakes. Quickly do the recorrections. Make it fast. Okay, Lamai. So R. So 5p plus p squared minus 24. Again, this is not something that I'm familiar with, so I'm going to rearrange. Can you all hear me, Lamai? So I'm going to rearrange and I'm going to bring p squared to the front. P squared. Then 5p, I'm going to take it to the middle. Minus 24, I'm going to keep at the end. Now our work begins. First term and last term, I'm going to multiply p squared minus 20. P squared multiplied by minus 24 would be minus 24 p squared. There are so many different ways. 1 times 24, 2 times 12. 3 times 8, 4 times 6. That would be it, no? Etakota 1 times 24. Komari add karahama plus 5p and 1 times 24 doesn't really sound like it, ne? 2 times 12. Then 3 times 8. Let's check that out. So, it's 3p multiplied by 8p. So, 3 times 8, 24. P times p, p squared. Sign එක minus නම් plus times minus වෙනවා. So, එක්ක plus 3p minus 8p එහෙම නැත්නම් minus 3p multiplied by plus 8p. You can check out other options too, right? Because then there's 4 times 6. 3 times 8. 4 times 6. 8 එක තමයි තිබෙන්නේ. So, you can try everything else. But සමහර වෙලාවට with the experience ඔයාලට ටක් ගාලා තේරෙනවා which one is the answer කියලා. So then I'm going to add these and see. Plus 3p minus 8p would be minus 5p. Minus 3p plus 8p would be plus 5p. And that is what we need. We need plus 5p. And we get plus 5p if we use minus 3p and plus 8p. So, p squared minus 3p plus 8p minus 24. If you take the first two terms, p is common, I take it out, I get p minus 3. Then if you take the last two, 8 is common, I take 8 out, I have p minus 3. So, we have p minus 3, p plus 8. Did you get this answer, Lamai?
Miss, instead of writing minus 3p and plus 8p, I put plus 8 and minus 3p. So the answer was p plus 8 and p minus 3. Is that okay?
Yeah, order come out, it's okay. Somehow the final answer is the same. The only thing is that order is different, but that is okay because if it was p minus 3 multiplied by p plus 8 or p plus 8 multiplied by p minus 3, it's the same. Okay. P plus 3 multiplied by, where is it? Sami, is this for the previous one? M plus 10, M minus 4. Yeah, that is correct, Samidua. That last I only saw it now. That is correct. Only the order is different. So that is okay. Okay, 2 minutes for recorrections. I think 2 minutes is too much. I'll give you 1 minute. Okay, quickly, because we have R and S too. Okay, Lama. Then let's move on to the next one. We have S. 45 plus x squared minus 14x. Again, this is not the same format that we have learned. So I'm going to rearrange this a bit, right? So x squared, I'm going to bring to the front. We have x squared like this, minus 14x here, plus 45. Okay. So as usual, we multiply the first term and the last term, x squared multiplied by plus 45x. We get plus 45x squared. So we are going to see different ways how this is formed. 1 times 45 whenever, 2 had 3 times 15, then 4 times 5 times 9, 6, 7, 8. So let's try 3 times 3x multiplied by 15x. So 3 times 15 is 45, x times x is x squared. So no problem. But look at the sign. Here it's plus. Plus when same signs are multiplied. Plus 3x multiplied by plus 15x or minus 3x multiplied by minus 15x. Common options we have 5 and 9 plus 5x multiplied by plus 9x. We get plus 45x squared. Minus 5x multiplied by minus 9x. We still get plus 45x squared. Then we are going to add and see. Plus 3x plus 15x. We get plus 18x. That's not what we want. What we want is minus 14x. Minus 3x. I'm going to write it a bit roughly. So my handwriting might not be the prettiest, but let's speed up. Minus 18x. That's also not working. Plus 5x. Plus 9x. Plus 14x. Okay, that's quite close. Minus 5x. Minus 9x. Minus 14x. And that is exactly what we want. And now plus 5x plus, sorry. Minus 5x minus 9x is what we want. Okay. So let's quickly write it down. X squared minus 5x minus 9x plus 45. If you take the first two, x is common, I take x out, so I get x minus 5. If you take the last two, I take minus 9 out, so I have x minus 5. So, what we get is x minus 5 and x minus 9. Is this clear to all of you, Lamai? Is this clear? Others? All right, 1 minute to for recorrections. Make it fast. All right. Lastly, we have t. N squared minus 28 minus 12n. N squared minus 28 minus 12n. I'm going to rearrange this. N squared minus 12n I'm going to bring to the front, and minus 28n, sorry, minus 28 I'm going to push to the back. All right. First term and the last term, let's multiply. N squared multiplied by minus 28, we get minus 28 n squared. We are going to see different ways how we can produce that. For an example, we can take 2 times 14. So 2n multiplied by 14n, we get 28n squared. Look at the sign. We get minus when we multiply different signs. Either plus 28 minus 14n or minus 2n multiplied by plus 14n. Both of these methods can produce minus 28n squared. Let's add and see. Plus 2n minus 14n. We get minus 12n. And minus 2n plus 14n, we get plus 12n. And what we want is minus 12n. For that, we have to use plus 2n and minus 14n. Plus 2n and minus 14n. So let's simplify. You get the common term out of these two. So we get n plus 2. From this, the common term is minus 14. I take it out. I get n plus 2. Then we have n plus 2, n minus 14. Is this clear, Lamai? What is any other homework that I give?
No, miss, that's it.
All right. Okay. 1 minute to copy this down. Then we are finishing the lesson today. All right, Lamai. So today's new part, we are going to, the same thing that we have been learning so far, we are going to extend it a little bit, right? Okay. Megara topic we will just put some more examples with the Rabikaramu. Now, first of all, I don't want you to write down. I want you all to listen, right? So example 1. We'll just do the same example as on the textbook. So we have to find the factors of this. Lama attatama, even when you're doing this, the theory that you learn doesn't change. It's the same theory, but it's slightly complicated. What do we have to do in the previous examples? What we have learned so far? I told you when you're given a question like this, you multiply the first term and the last term, right? So let's do that. Let's multiply the first term and the last term. First term is 3x squared, last term is 15. So 3x squared multiplied by 15. So 3 times 15 is 45. We get 45x squared. Math plus, so math plus. Then we are going to see different ways how plus 45x squared is produced. So 1x see, same thing. 1x multiplied by 45x. So 1 times 45 is 45. X times x, x squared. If you want to get plus, we have to multiply same sign. So plus 1x multiplied by plus 45x, or minus 1x multiplied by minus 45x. Okay. I have to pull on 2 times, where 3 times pull on. Plus 3x multiplied by plus 15x, or minus 3x multiplied by minus 15x. There 3 times, 4 times, 5 times pulwane. Plus 5x multiplied by plus 9x, or minus 5x multiplied by minus 9x. So these are all the different ways how we can produce plus 45x squared when multiplied. Now, all these methods, we are going to see what happens when we add them, right? Plus 1x. Same thing that we learned last week. Plus 1x plus 45x, we get plus 46x. Minus 1x minus 45x, we get minus 46x. Plus 3x plus 15x, we get 15, 16, 17, 18. Plus 18x. Minus 3x minus 15x, yes, we get minus 18x. Plus 5x plus 5x plus 9x, we get plus 14x. Seems like this is the answer, no? Minus 5x minus 9x, we get minus 14x. So these are all the different ways how we can produce plus 45x squared. ඊට පස්සේ ඒවා add කරාම මෙහෙම එනවා. Here our middle term is plus 14x. Out of these, plus 5x and plus 9x produces plus 14x. So plus 5x and plus 9x is what we have to use. Let's go here. 3x squared, I'm going to write as it is. Here, we use plus 5x plus 9x. Then, 5x and 15 would have, so look at this here. A little something. Then මේ දෙන්න ගත්තොත් මේ දෙන්නගේ common x විතරයි නේ. x විතරයි common. මේ දෙනා ගත්තොත් මේ දෙනාගේ 3 විතරයි common. So instead of doing that අපිට පුළුවන් මේ දෙනා මාරු කරලා ලියන්න චුට්ටක්. plus 5x plus 9x ලියන්න නැතුව we can write plus 9x මුලින්ම and then plus 5x. Why do I do that? Because then there will be more common elements. I mean, if you want, you can do it like that. But if not, අර විදිහට ලිව්වත් කමක් නැහැ. Okay? So sometimes when you think of it, it might be easier for you to like maybe rearrange the terms a bit. But අපි දැන් ආපු විදිහට කරලා මම පෙන්නන්නම්. Other method also might be easier, just changing terms here and there, right? Okay. Now, if you look at 3x squared plus 5x, what is common here? X is common. Yes, x is common. So I take x out. 3x squared වලින් x වගත්තම I get 3x remaining. From 5x, when I get x out, I have 5 remaining. Plus, from 9x plus 15, what is common here? 9x and 15, what's common?
3.
3. So from 9x, when I get 3 out, I get 3x. From 15, when I get 3 out, I get 5. So we get 3x plus 5 and Eli innava x plus 3. Even when you rearrange the terms, sometimes the simplification would be easier, but still you would get the same answer as the final answer. Did you all understand this, Lamai? Give me a thumbs up if you did. Okay, can you all copy this down? There's no like specific topic for this. This is just today's section. There's no specific topic. So quickly copy this down. I'll give you 4 minutes. Quickly copy down. Okay. Let's do now when you look at this method, what do you think? Is it easy or difficult? Compared to what we learned last week, do you feel that it's the same thing? The only difference is that method at Bella. But still the method is the same. So easy. What do you think, Lamay?
It's easy, just that number thing makes it a little hard.
Yeah, it makes it a little bit harder, but it's an extension of exactly what we have been learning. Easier. Yeah. So, how about instead of doing another example, shall I give you a question to try? Then අපිට එකම method එකනේ. The only thing is that there's an extra number, but it's the same method repeating.
Okay,
So
miss.
yes. So එකම ඒවා අපි let's not it's not exactly a waste of time, but I think we can move forward faster if maybe we'll do another question, but I will give you the question to try alone. Let's try. Mm, 2p squared minus 14p plus 24. Okay, Lama, quickly do this. I won't set a timer, but quickly finish. Make it fast. Same method, huh? Let me know when you're done, Lamai.
Done, Miss.
Others? Who else has finished? Okay, let's slowly start to discuss. Okay, good. So 2p squared multiplied by 24. So that would be plus 24p. Sorry. 2 times 24 is 48. So that would be plus 48p squared. There are like so many different ways, right? 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 by 6 times 8, 7 by 8 times 6. Likewise, there are so many different ways. So out of all the different ways, I'm going to see what is the most suitable. I mean, if you want to, you can write everything, but that's going to take some time, right? When the more questions you do, the more experience you have, then you will not have to write an entire list like this to figure it out. I'm going to take plus 6p multiplied by plus 8p. So 6 times 8 is 48, p times p squared, plus times plus plus. Or we can get minus 6p multiplied by minus 8p. Because 6 times 8, 48, p times p squared, minus times minus is plus. Now we will add. Plus 6p plus 8p is plus 6p plus 8p would be plus 14p. Then minus 6p minus 8p would be minus 14p. And this is what we want because we have minus 14p. Then we will write it 2p squared minus 6p minus 8p plus 24. Let's take the common ones out here. 2 is common, p is common. Medinagata 2 is common and p is common. So 2p squared gang 2 and p gathama, I have p remaining. Minus 6p again 2p gathama, I have 3 remaining. Minus 8p minus 3. So we have p minus 3, 2p minus 8. So this is how I get the answer. Did you all get this answer? Is this clear?
Yes.
All right, good. Now I'm gonna discuss an example with you. One more example. This is slightly different. Huh?
Miss, I got p minus 4, 2p minus 6.
What is it? P minus?
4, 2p minus 6.
P minus 4, 2p. What is it, Ismail? Minus 6.
2p minus 6.
6 times 4, where the 3 times minus 8p. Minus 6p and all right, okay. Minus 8p, yeah. That should be correct. So that means, let's see if this is correct. So according to Maria, metana dala thiyena menna me vidiyata. Maria also has done the same way. 2p squared minus 8p මුලින් ලියලා ඊට පස්සේ minus 6p plus 24. Let's see if that is correct. So if you take the first two, 2 is common, p is common, I take it out. I have p minus 4. Here minus 6 is common, I take it out. I have p minus 4. Then p minus 4, 2p minus 6. So yes, that is also correct. Both of these are correct. They both give the same answer. Yeah. All right, next one. We are going to try a slightly different example here. Make a liyan pa. First look at me doing this on the board. 2a squared plus 13ab minus 7b squared. So this is slightly different than one last term squared එකක් ඇවිල්ලා. However, let's not panic. Right? අපි panic වෙන්නේ. Whatever we have learned, we are going to use it the same way and we'll see if it works. First term is 2a squared. First term is 2a squared. Last term is minus 7b squared. So I'm going to multiply these two as usual. 2 times 7 is 14. A squared, b squared. A squared, b squared. May plus, may minus. So answer get minus. So we have minus 14 a squared, b squared. So we have to find different ways how we can produce this. I'm going to give me up to this point, did you understand? I took the first term 2a squared, last term is minus 7b squared, and I multiply, I got minus 14 a squared b squared. Alright? Okay. 1 times 14. So a squared b squared that also gets broken down. This gets from a squared, one a goes here, another a goes here. From b squared, one b goes here, the other b goes here. So metana minus nang plus 1ab multiplied by minus 14ab. So 1 times 14, 14 plus times minus minus. AB multiplied by AB is a squared b squared. So that's all good. Mehemat puluwan minus 1AB multiplied by plus 14AB. That's one way. We can also take plus 2AB minus 7AB. Or minus 2AB plus 7AB. It's rapid options. Now we will see, we will add and see. Plus 1AB minus 14AB. We get minus 13AB. What do you want here? Plus 13AB. Minus 1AB plus 14AB. We get plus 13AB. That is what we want. No, because here we have plus 13AB and we know how to get it. See? Minus 1AB plus 14AB. Minus 1AB plus 14AB. So here 2a squared minus 1AB plus 14AB minus 7b squared. So I take the common one out here, 2a squared and 1ab again common it's just 1. Sorry, it's just a. 2a squared when I take a out, I get 2a. From 1ab when I take I have 1b. 1 එක දාන්න ඕන. I can just write b. Then from this, plus 14ab minus 7b squared කියන එකෙන් I can take plus 7 out, and I also can take a b out, right? So 14ab against 7b gatham, I have 2a remaining, minus 7b squared against 7b gatham, b is remaining. So within the brackets, I have 2a minus b and a plus 7b. Is this clear to all of you, Lamai? Others? Okay. Can I copy this down real fast? Quickly copy this down. Then we have only one more section for the lesson. It passive, we just have to do more and more questions.
Miss, is A plus 7B 2A plus B also correct?
Sorry, can you repeat again?
Is A plus 7B 2A plus B also correct?
Then it can't be 2a plus b. It has to be 2a minus b, for sure. That sign cannot change.
Oh, thanks.
Okay. Quickly right. Others also, if you all have questions, please do ask. These are very important in mathematics. Algebra related, they were very important. So if you have any questions, anything that you didn't understand, any concerns, anywhere that you want me to clarify, please let me know. Done writing lamai? Okay, others? Okay. I will give you the homework at the end, but let's move on. Can you put a subtopic? Difference of two squares. Difference of two squares. This is the next section that we're going to learn. Okay. Now for an example, if you take something like, let's say, x plus y, x minus y. I want you all to solve this. Can you solve this and tell me the answer, please? X plus y, x minus y. Solve this and tell me the answer. Solve this. We learned this in the 4th lesson.
X,
X squared minus y squared.
Okay, Basma, we'll see others.
Plus
Only we
x
can
squared
still.
minus y squared.
Okay.
X
Do others
squared
also agree?
y
Okay, we'll see. X times x is x squared. X times minus y is xy, plus times minus, it's minus. Then y times x is still xy, but plus times plus, it's plus. Then y times y is y squared, plus times minus, it's minus. We can see minus xy plus xy, then a cancel venane. So what we have remaining is x squared minus y squared. In other terms, මෙයාගේම opposite එක ගත්තොත්. In other terms, x squared minus y squared is the same as x plus y, x minus y. Okay, so this is called difference of two squares. What this means is that, let's take another example. Example 1. Let's say you have two square terms, right? අපි ගමු p squared. So this is one square term, q squared. This is another square term. If this is a difference එකක් කියලා කියන්නේ always it's a subtraction. Difference means subtraction, it's minus. So we have, this is the difference of two squares. There are two squares, it's a difference. That's why we have a minus. This is how you simplify in one step. What do? You open two brackets. Metan p squared, p squared, there are two p's. One p I put here, the other p I put here. Then here we have q squared. From the q squared, one q I put here, the other q I put here. Metan difference එකක්, but in the two brackets, එකකට මම plus දානවා, අනිත් එකකට minus දානවා. This is the shortest way how we can simplify something like this. Did you understand that? මේක තමයි long method එක. Long method එක නැතුව අපිට short method එකෙන් කෙලින්ම යන්න පුළුවන්. Okay, let's take another example like this. Here, if you look at this, x squared and y squared are square terms. This is just the method because it's a shortcut. අපි සාමාන්‍යයෙන් කියනවා මෙහෙම minus එක තියෙනවා නම් there are two terms. p squared වලින් එක p එකක් එක bracket එකකට යනවා, අනිත් එක අනිත් එකට යනවා. From q squared, one q goes to one bracket, the other q goes to the other bracket. When it comes to the two signs, one bracket should get a plus sign, the other bracket should get a minus sign. That is a standard method. Okay. So just to double check, ඔයාට මෙයාවම simplify කරලා බලන්න පුළුවන් ආයෙමත් මේක එනවද කියලා. Here මෙයාව simplify කරලා we got this නේ. ඒ වගේ you can check By simplifying p plus q, p minus q, if you get this, and you will get it. So you can just double check. Make a gatham, x squared is a square term, y squared is a square term. What about 4 and 9? ළමයි බලන්න මෙතන 4 we can write as a square of something. We can write 4 as 2 squared. X squared is anyways a square term, minus 9 I can write as 3 squared. And we have y squared. Okay. In this method, everything has to be square. Then what do? I open two brackets. From 2 squared, 1 2 I put here, the other 2 I put here. From x squared, 1x I put here, the other one I put here. From 3 squared, 1 3 I put here, the other 3 I put here. From y squared, 1 y I put here, the other y I put here. Then මැදට එක්කෙනෙක්ට plus එනවා, අනිත් එක යන minus එනවා. This is how I write difference of two squares. Is this clear to all of you? Please give me a thumbs up. Others? What about if you get something like this, slightly more complicated? If you consider our third example, can you consider it as a difference of two squares example? Can we consider it as a difference of two squares example? Yes. Why? මෙතන අපිට square term, I mean, inside the bracket there may be a lot of different elements, but it's still a square term. මේ මුල එකේ නාගත්තොත් it's a square term, this is a square term. Then මැද minus එකක් තියෙනවා කියන්නේ it's a difference. So this is difference of two squares. Then what do? I open two brackets. The මෙතන මෙයාගේ already, this one already has a curvy bracket, right? So if I open another curvy bracket, it's going to be confusing. So in this case, I'm going to open two square brackets. So from x plus 2 squared, 1x plus 2 I put here. The other x plus 2 I put here. From y squared, 1y I put here. The other y I put here. Then to the middle, for one bracket I put plus, for the other bracket I put minus. Is that clear, Lamai?
Yes, why don't we change the x plus 2 one to x plus 2 and x minus 2?
X plus 2, you're asking why we are not simplifying x plus 2?
No, why don't we change the inside symbol?
That is because this entire thing itself is a square. Sorry. This entire thing itself is a square. X plus 2 කියන එක්කෙනාගේ square එකනේ තියෙන්නේ. එතකොට I can't change anything that is inside the bracket because the bracket itself is a square. The bracket එක වගේ දෙකක් ඉන්නවා එතන කියන්නේ. X plus 2 multiplied by x plus 2 තමයි x plus 2 squared කියන්නේ. Just like y multiplied by y means y squared. X plus 2 multiplied by x plus 2 is x plus 2 squared. So එතකොට when you are breaking it down into through brackets, from x plus 2 squared, one x plus 2 goes to one bracket, the other x plus 2 go to the other bracket. Is it clear, Smile?
Yes, Miss.
All right. Now for further simplification, ඇතුළේ ටික මොකද කරන්නේ? දැන් ඔයාලට මෙතන x plus 2 මෙතන නිකම්ම වෙන මොකුත් multiplying නෑනේ, it's just addition නේ. Plus y කියලා කෙලින්ම මට ලියන්න පුළුවන්. Here x plus 2 minus y. This is how we get that answer. Is that clear again to all of you? Okay. Let's look at the fourth example too. Then I will give you time to write. P minus 2 squared. P plus 5 squared. Again, we have two square terms. P minus 2 squared, P plus 5 squared. Method difference එකක් තියෙනවා. That means method negative එකක් තියෙනවා. So it's a difference. Now, since there are already curly brackets, in order to avoid the confusion, I will put square brackets. So P minus 2 squared වලින් එක P minus 2 එකක් I put to this bracket. The other P minus 2 I put to the other bracket. From P plus 5 squared, 1 P plus 5 I put to one bracket. The other P plus 5 I put to the other bracket. For the middle, in one bracket I put plus, for the other bracket I put minus. Then let's simplify this further. Here we have P minus 2. Method plus times plus is plus P, plus times plus is plus 5. මෙයාගේ P minus 2 එහෙමම ඉන්නවා. Here, minus times plus is minus P, minus times plus is minus 5. So, here method plus P and plus P. Plus P means plus 2P. Minus 2 plus 5 means plus 3. Here, plus P minus P can be plus P and minus P cancel them. Then minus 2 and minus 5 means minus 7. So this minus 7 I can write it at the front. Minus 7 2P plus 3. Is this clear to all of you?
Excuse me, teacher.
Yes, Basma.
So the squared P minus 2, it's a different square, right?
P minus, this one you mean?
Yes. So
Yeah.
why don't we write it as P minus 2 and P plus 2?
Here we wrote it like that. Here P minus 2, P minus 2, P plus 5. You mean this itself? Because this
Yes.
itself is a square.
Yeah.
A capital ලියන්න බැරි because P minus 2, that entire unit is a square. But this is not P squared and 2 squared. That's just P minus 2 squared. Okay, so let's clear out that confusion. So P minus 2 squared is 1. P squared minus 2 squared is 1. Do you think these two are the same thing? P minus 2 squared, when you simplify, you have learned how to simplify the square of a binomial expression, right? Mulima, you take the first term, you take the square of the first term. First term is P gets square ka P squared. Then first term multiplied by second term multiplied by 2. So 2 times 2 is 4, 4 times P is 4P. Plus times minus is minus, minus times plus is minus. Then you take the square of the second term. So P minus 2 කියන මුළු unit එකේම square එක ගත්තොත් you get P squared minus 4P plus 4. But this is just P squared minus 2 squared. එයාව මට ලියන්න පුළුවන් P plus 2 and P minus 2. So these are two different things. When I say P minus 2 unit එකේම square එක, that is one thing. If I say P squared minus 2 squared, that is a different thing. Okay, Basma?
Teacher, thank you.
Did you understand that?
Yes, yes.
Okay. Anybody, if you did not understand it yet, please let me know. How did 3 come? 3 where? Here. Here, Balanda, make a simplify the P minus 2. Then my brackets take a simplify. I'm just simplifying the brackets. Plus times plus P is plus P. Plus times plus is plus. Here we have 5. Method bracket simplify around P minus 2 as it is. Then minus times plus is minus. So minus P. Minus times plus is minus. So minus 5. Then here plus P means plus 2P. Then minus 2 plus 5. When you add, when you simplify minus 2 plus 5, you get plus 3, no? Did you understand that, Samidu? Right. On the other hand, here we have plus 5, here we have minus 5. Plus minus cancel වෙනවනේ. So, ඒ දින කැපිලා යනවා. Here we have minus 2 and minus 5. They together will form minus 7. Is everybody crystal clear about this? Do you all need any clarification? Anything that you want me to clear out? Shanaz, it might be, can others hear me? Shanaz, it might be a connection issue from your end. Can you double check? Also, meanwhile, others, everybody tell me, Alia, Basma, Ismail, Kushit, Savindu, is it clear?
Yes, teacher.
All right.
Yes,
Now let's,
teacher.
okay, good. Now let's copy this down, Lamai. Minus 7 now metana. Did you understand how we got this, Savindu? Okay. Now here we can see this is plus P and this is minus P. Plus and minus capilano always plus and minus capilano. So plus P and minus, that means P innawa P again P was subtract වෙනවා. Here this is plus P, this is minus P. Plus P again subtract වෙනවා P வை. So P again P was subtract from it's 0. Then here minus 2 minus 5. So minus 2 minus 5 means there are 5 minuses. So altogether that's 7 minuses. So minus 2 minus 5 is minus 7. Did you understand it, Samidu? Okay. Were there any other? So why can't we take P squared minus 2 squared as P minus 2 squared? Because both of them are squared. So Ekit Maria, the same thing here. P minus 2 squared is not the same as P squared minus 2 squared. Because P minus 2 squared simplify කරාම අපිට එන්නේ P squared minus 4P plus 4. But මෙතන තියෙන්නේ P squared minus 2 squared is minus 4, right? 2 squared is 4. So okay, look at the board again. මෙයාව simplify කරාම අපිට එනවා P squared minus 4P plus 4. But මෙයාගේ තියෙන්නේ P squared minus 2 squared is 4 and 2 times 2 4. So is this and this the same thing? Are they the same thing? No, if they are not the same thing, that means these two are also not the same. P minus 2 කියන unit එකේම square එක is one thing. P squared minus 2 squared means another thing. They're two different things. Is that clear? Did that answer your question? All right. Okay. I think most of you have already started copying down. I'll give a few minutes. Let's wrap up by exactly 9:42. I'll give you 2-3 minutes to copy down. Then I have to give you the homework. The key to this is, the key to perfecting this and mastering this is obviously doing more and more questions. And don't worry, we got that covered. We have a lot of questions in our exercises. We will do those. We'll make sure that you guys have a lot of practice. That whenever you see a question, you should be able to like quickly tell the answer or figure out the answer. That's the level of practice we need. Quickly, right? Okay, Lamai. Have you all copied down, everybody? Anybody who needs more time? All right. Maybe Kiki api. Okay, all right. While you copy down, maybe Kiki, let's focus our homework mostly on this lesson that we just learned, rather than focusing on previous lessons homework. But in the coming weeks, we can of course focus on those two. Exercise 7.2. Exercise 7.2, okay. Yes, that's a very good point that you raised. We have the class on 3rd of April. Good Friday. දවසේ උදේ අපේ class එක තියෙනවා. We put the time from shall we put it at like from 7:30 a.m. to 10 a.m. because you remember one week we missed a class. This is the extra class that I said. Yeah, no? Yes, it is there. I will send a link for that. And we will do the class on 3rd. That means day after tomorrow. Anyways, make a first a do JKL. Then in exercise 7.3, second one, HIJ. It's okay, Maria. I will definitely release the recording. I will send the recording in the group. 679. All right. Only 3 days. That was some exam. Them that was student. Okay. So even when you're practicing for your term test, if you get any question, you can let me know. Right? Miss Divya had dala tiyane to amara forward karna. Then exercise 7.4. Do HIJ. Yeah, do these questions and come for next week. This is all for the homework. Monday. Okay. Then up to which lesson are you getting, Maria? For first term. For first term, did you all do triangles at school? All right. Okay.
No.
No. Okay. Some of you have done, some of you have not. But api vacation ke pulantara ikmane catch up karam. Right? Okay, Lamai. Then let's wrap up. Let's meet next week, Neve, the day after tomorrow, 3rd of April. At 7:30 a.m. sharp, we will have the class. And until we meet next week, have a great week. And if you have exams, good luck for your exams. And see you next week, Lamai. Good night.
Good night, teacher.
Thank
Thank you,
you. Good
teacher.
night.
Good night.
Good night, teacher.